write down 5/10 on your paper. Just 5/10. Bennett, are you ready? 5/10. I want you to circle the numerator. I want you to square the denominator. And I want you to come up with that fraction in simplest form. What does that fraction equal in simplest form? Write it down. Circle the numerator. Draw a box around the denominator. And write that fraction, 5/10, in simplest form. Oh, good. In simplest form. What's 5/10 in simplest form? Think about the work you've done in 4th grade. Good so far. You just need to write it in simplest terms. Think about what 5/10 is equivalent to. What's it the same as, equal to? What's a simpler way? If you had to draw a picture of 5/10, what would be a simpler way to draw it? If you drew a picture of 1/5 and 5/10, would they look the same? No, they have to be equal. All right. There's a couple people I didn't check. Perfect. All right. So who can tell me what to circle? What should I circle? Sarah?
You circle the 5.
The 5. The 5 is the numerator. Who can tell me what to draw a box around? Julia?
The 10.
The 10. The 10 is the denominator. What's 5/10 in simplest form? Ronan?
A half.
A half. 1/2. Why is 5/10 simplest form 1/2? I'm going to give you some wait time because I want everyone thinking about this. Why is 5/10 the same as 1/2? Or why is 5/10 simplest form 1/2? Who can tell me? We should be linking to our prior understanding. We know in 4th grade we talked about simplest form and numerators and denominators. So we're going to build on that today. What do you know already, Camille?
1/2 is a unit fraction.
Ooh, we talked about that yesterday. 1/2 is a unit fraction, so we know it's in simplest form. But how do you know that 5/10 is equivalent to 1/2?
Because 5 is half of 10.
Okay, so you could do it that way. Some people use that way. Any other ideas? Evan?
The only number that the numerator, there's
Okay.
that the numerator and denominator are both divisible by, that you can get the lowest number. It's 5 divided by 5 equals 1, and 10 divided by 5 equals 2.
Oh.
You can't get any lower than that.
Okay, I like that. I want somebody to build off of Evan's ideas. So we know 5 and 10 are both divisible by 5, and then we get 1/2. What about 1/2, besides it being a unit fraction, tells me it's in simplest form? Think about it. Take a minute. What can't you do? Can you come up with a rule or build on what he just said? We need a little more detail. I see the same hands. I want some more people, so I'm going to give some time. Think about that. Nadia, was that a hand?
Yeah.
All right, go ahead.
Because 5 times 2 equals 10.
Okay.
Which that means 5 is half of 10. So then it would be like 1 is half of 2.
Okay, so that proves that they're equivalent. But why is 1/2 in simplest form?
Because you can't go any further down than that. Like, you can't go to decimals because that would be too low.
Okay, it's not because I can't go to decimals, but you're on the right track. There's something I can't do here. What can't I do? That's what I want to know. How do I prove, if somebody didn't believe me, how do I prove that's in simplest form? What argument would you tell them? How would you prove it? Jenny?
Well, in order for it to be in simplest form, then the only multiple that the numerator and the denominator should have in common is 1.
Okay, the only multiple?
Yes.
Does everyone agree with that? The only multiple they'll have in common is 1. So I'm going to find multiples. 1, 2, 3, 4, 5, 6. I'm going to find multiples of 2. 2, 4, 6, 8. Do we all agree that the only multiple they have in common is 1? No. Some people are shaking no, so why not? What's the word I think Jenny was looking for? Kelly? Factor. So let's say it again with the right vocabulary. Go ahead.
Well, the only, like if it's in simplest form, then the only factor that the numerator and the denominator should have in common is 1.
There we go. So the only thing that 1 and 2 can both be divided by equally is 1, and that's how we know it's in simplest form. You can tell me which of these 4 have a common denominator, another good vocab word we need to know? Let me check down.
3/4 and
1/4 and 3/4. Why do they have a common denominator, Devin?
Both of their denominators are 4.
And what does 4 represent? I'm going to let somebody else share. Molly, what does 4 represent? In this fraction, 3/4 or 1/4. Sometimes it's, go ahead.
It's the denominator in both.
It's the denominator in both. What does a denominator in a fraction represent?
The whole.
What about the whole? It does, in a way, represent the whole.
How much the numerator is.
If you were to draw a picture of 3/4, how would you draw it? Hands down.
You would make 4.
For what?
For like pieces.
Yeah, 4
and then
parts
3
or pieces?
Yeah, and then 3 would be like shaded in, or
Okay, so what did the 4 represent in your picture?
how many pieces?
You got it. How many parts in the whole? So you kind of had to combine your 2 ideas. So if I ask you to do that problem, we should spark a plug in our memory that we're in 4th grade and we remember how to do this. This is what we're going to build on today. This is what we're building on today. This is what we're moving on towards. Clara, what do you think? What would the answer to that be? 5, 6. Who can prove Clara's thinking? Who thinks that you think it's 5, 6 also? They're going to prove it. Prove it to me. Grace.
2 plus 3 is 5.
Okay.
And the 6 is the same.
Why do the 6 stay the same? You're right. Grace says she thinks it's 5, 6. If I had a picture it would be the same. Why? I don't know why that's doing that to me. Why? Who can prove it? I'm going to draw a picture once Smartboard cooperates. Who can draw a picture of that for me? There we go. Who can prove it? 2 plus 3 more. Why is it 5, 6? How about 5/12? 2 and 3 is 5. 6 and 6 is 12. Abigail, what do you think? What do we think? Grace says 5, 6. I say 5/12. Who do you agree with? Why? Why? Brody.
Because when you do 3 plus 2, you just add 5, and 5 isn't a whole yet,
Okay.
and it's still 6.
What was it, 5 or 6 though?
It's 5,
5 what?
6.
Why though? Why is it 5, 6 and not 5/12? I agree with you that the top number, the numerator, is 5, because I have 5 pieces all together, right?
Yeah.
1, 2, 3, 4, 5. 5. Why is this 6 though? Ronan.
You can't add denominators,
Why not?
because then it would add up to more than it actually is.
Why?
Because when you're adding the numerator is parts of a whole. and
Okay.
6, you're not adding more wholes to the number.
Okay.
There's only 6 pieces. So you can't add, like, the bottom number is how many pieces there are in total. 5 is how many pieces there are. If you're adding 2 pieces plus 3 pieces, you'll get 5 of the 6 total pieces.
Okay, so 6 is naming the...
6 is naming the whole. Wait, but I also wanted to say, it's kind of like, if you did that and you said 5/12, you said this before, it's kind of like adding like 2 apples plus 3 apples and getting 5 oranges.
Yeah. What? So then what? That somebody put their thinking together in their own words. What is that doing? If I add those denominators, why doesn't it work? Charlie?
Well, you're saying that I make 4 pieces to make a whole.
Okay, first of all, I'm changing what my whole looks like, right?
Yeah.
So I go from my whole looking like this to my whole... Oh, and I made these fifths, didn't I? 1, 2, 3, 4, 5. Ah! There we go. I go from my whole looking like that to... I'm going to run out of space. To looking like that. So I can't change my whole. The denominator... Yeah, I know. I was trying to make it so the parts would seem comparable. What is the whole representing, Maverick?
It's representing how many pieces it takes to get to a whole.
To get to a whole. So it's really naming the parts. It's almost like a label, and that's what Bennett was talking about before. All right, so today we are going to be using what you did in 4th grade to build upon that understanding and do something a little bit different because our problems are going to have different denominators. So I'm going to pass out 2 materials to you. Eyes on me, hands free, please. One is the work we're going to be doing. The other is going to be a set of fraction equivalency cubes. We've used those before. With your partner, I want you to do the investigate. I want you to think about how you could add 2 numbers with different denominators using those equivalency cubes. We know it doesn't work, so how do we make it work? That's your job. All right. Spot 1, people. Except for this table. Camille, you can do your spot. I want you to go back to the back table and get your table 4 or 3 sets. So it's Kaden, Maverick, Camille, Bennett, Sarah, Julia. Go ahead.
How many sets?
1 for each person at your table. Sorry, Kaden. No, keep them out. You might need them for some of your work. All right, looking for it with quiet. Pew pew, transition. I like how Kelly's putting her name and Billy is getting his material set.
So I'm actually scratch clean tape.
No, you can actually work right on here, and then if you need scrap paper, you can work on that.
So we're working in partnership.
All right, step 1. Give me 25. Okay, what I want you to do, directions repeated. Who thinks I can tell me the directions back? Directions back. Oh, hands aren't free, hands free. Okay, Kelly's speaking. Eyes on her, please.
We're gonna do the investigate with our partner and with the fraction cubes.
Fraction cubes, we're running hands free. Okay, what's the goal? Why are we using these cubes? What are we gonna investigate? What are we trying to solve?
Use models to add fractions with unlike denominators.
Use models to add fractions with unlike denominators. What's key? What do we need to do when we work with somebody? Think of our partnerships. What are our math practices? What are we going to make sure good mathematicians do, Kaden?
You have to understand the math problems and keep trying to solve them.
Yeah, so persevere. We talked about that. You guys are making me laugh. Julia. Say again? Explain. Exactly, Julia. All right, go ahead and investigate. I know, you are going to investigate. Who did I have you working with? I know besides Laura. It was Molly's group, right? Molly, Camille's going to join you because Laura's not here. Okay? So just grab why don't you 3 for now sit at my back table? Yes.
Okay. So I gotta figure out investigate.
Is something wrong with your set? Try that one.
Or 3/4.
I'm going to leave this here for you in case you have to combine sets or something, Charlie.
2/4 equals 1/2.
Yes. Okay. I love that you both have great ideas, but I want to see it modeled and I want to see that conversation. Explain what you're doing.
Oh.
All right.
Colin,
So model it out,
I
please.
did what Colin said.
I just figured
Okay.
it out.
Well,
and I was just
I'm
like,
not saying he's wrong, but did you learn anything by just writing down what Colin had? No, right? So let's work together, Colin. So get your equivalency cubes out because I want you to model it. That's part of the practice. I have other problems for challenges, but I want you to model it. You need to practice and understand why.
1, 2, 3, 1.
So what do you have? You have a whole, okay, and then 1/2 plus 1/4. You have how many there?
this is how I did it, though. I could just tell you how.
Absolutely, I want to hear how you did it, but I want to see it modeled also. Nope, just that one problem. You need to model it, Bennett. Leave it out. I want to see the model.
Okay, 1/2
Okay, I wanna
is
see
equivalent to
the
2/4. So 2/4,
Excellent.
1/4, 3/4. Boom, I figured
Snap
it out.
once. Make 50. You're not making 50 if I can hear your cubes. I know some of you have ideas, and I want to hear those ideas of how you solved it, but I also want to see the model. The model is going to help you to understand why your strategy works. So let's see the model. You got another couple minutes, and then I want to share out. What'd you do? Nice. All right, so do you know what the next step is?
All right.
I would link these. Yeah, but can you add 1/2 and 1/4? What would you use as a denominator? Right? So what you need to do is find what could you use that would equal the same sum as 1/2 and 1/4, but using only one type of unit, using only one common denominator. So it has to have the same denominator and be equivalent to 1/2 and 1/4 together. Awesome. I love it. How's Ronan doing? All right, so he has his model built. Maybe you can share some of your thinking with Ronan, how you've discovered which one would work.
Alright, so Roman, we're trying to find
What do you think might work to model the same as that?
how to model the same as
Try it.
75%.
You might have to take some off. It might not be the total. How did you two do? Ooh, I like that. Did you guys share your ideas? And I like your work too. All right. So Claire, you're not making a hole, and I'll show Sarah too. Let me borrow this perspective. What you want to do is find out what would be equivalent to this sum. So 1/4 plus 1/2 equals this. What could you use from your fraction strips to make something that's equivalent to the sum of that? So what could you try? You don't want to add on to it, Sarah. You want to find something that's equivalent to what you have already. So which fraction strips with the same denominator could you put under here that would be this equal? I don't know if I stole that from you or Sarah. Let me see your model.
It's equivalent to 2/4. And 2/4 plus 1/4 would be 3/4.
3/4. How do
Which
you...
is equivalent to 1/2 and 1/4.
Perfect. How do you know? How did you know to pick fourths?
I didn't pick fourth. Well, it's the only logical one, but it's adding a fourth.
Okay, what if somebody didn't understand your logic? How could you explain it?
I decided to do it because 2/4 and 1/4 both have like denominators, so they're easier.
What kind of denominators?
They have fourths.
Fourths. What if they both have them? It's a what?
They're like denominators. They're
So what's the word we use?
Common.
fraction.
Say it.
The common denominator.
Common denominators.
Ah, I said
All right.
like.
How'd you do?
So what do you do when you're done? You eat or
Awesome.
put. Good idea. But I don't have a
Yeah.
spread file. See.
How'd you guys do? Okay. Snap once. Snap twice. I like how some people are really being responsible with their tools, their math tools, and they are showing me that they are very responsible. All right, who can share with me how they developed their thinking? So hands are free. If you did not finish, we're going to develop it together. Who can tell me what they did? How did they develop that? What did you do? What did you think? Kaden.
Well, I took 2 of the fourth blocks and I put
Okay.
it next to the half block.
Okay. So
And,
first, Kaden, before you even did that, how did you model out 1/2 plus 1/4?
I
I'm gonna model up here, that's why I'm asking you.
Like this.
Okay, so one, is that, well, you did 1/2. Did you put it below it, Kaden?
Yeah. I put it like next to it.
Next to it,
like
because you're adding them, right? So 1/2 and 1/4. And then Kaden, what did you say to yourself?
Well, I said 2 of these equals 1 of these.
Okay, can you name those?
1/2 or 2/4 equals 1/2.
Okay.
And then if there's one more 4, it makes it 3/4 instead of 2/4. So it's 1 more than half.
Okay. I'm gonna have somebody restate that. Tell me again. We're gonna play with them in a second. Again. Just leave them. Thank you. Dominica.
1/2 is equivalent to 2/4.
Okay, so same as Kaden said, 1/2 is equivalent to 2/4, so I can model that, and I can write that too, right? So really, I'm making what was 1/2 into 2/4. All right. And then, who can explain the second part, what Kaden said about how she found that last part, or how she knew? I should be up here. Maverick?
Because the last part says it's 1/4.
It's 1/4. What do 2/4 and 1/4 now have in common? Maddie, what do 2/4 and 1/4 now have in common?
That they have both the same denominator.
They have what's the proper? Means the same. They have it in. If you and I both like basketball, we have that in. Yeah, common. So they have common denominators. So Maddie, what would the answer be? Hillary uses how much yards of fabric?
3/4.
3/4. All right, I want you to try and investigate another one, but this one you definitely need to work with your partner on, and that should be a little bit of a hint.
My it only came out with 3. Only came out with 2.
2/12? Okay, so yes. Let me see what we got. Why didn't you raise your hand? That's that's still right. You need to simplify it though.
And 6.
Yeah, I found that. I put them all next to each other. I put all of them next to each other, and I took off pieces to see which one it would make.
Awesome. Save that.
I found that too.
Work with Evan on the next one.
I'm confused.
That one. Yeah.
Yeah, he actually did. Right.
I need you to focus on the task.
This one.
Okay, so you're going to keep eating them, so you actually want to keep them out. Okay?
The next page.
Yep, the next page.
What?
And I want you to model it and work through it together. So
What is your problem, Jenny?
let's read it together. Can you read the top part?
What is this? This is make connections.
Yep. Can you read the top part, please?
I can't.
The other part.
It's too blurry.
I know, I'm asking Colin too. Can you read the top part, please?
Sometimes the sum of two fractions is greater than 1. When adding fractions with unlike denominators, you can use the one whole strip to help determine if the sum is greater than 1 or less than 1.
So it's 3/5 plus 1/2. So what I want you to first do, here's your whole. I want you to model that below it.
What, 1 whole?
No, the addition problem.
1 whole. Okay.
Maddie, not a good time. I have 12s for you. What'd you get? So put them together because you're adding them. You needed which? Ace? Okay, so first of all, what do you even notice there, Kelly? It's over. You think other people notice that? Snap once, snap twice. Tell me the first thing you noticed when you went to put 3/5 plus 1/2. Hands free. Check it out. What's the first thing you noticed when you went to put 3/5 and 1/2 together? I'm adding them. What did you notice? Dominic, what did you notice? It's larger than 1. So it's more than a whole. So when you're doing this, is your answer going to be more than a whole? Yes. All right, keep going. Make sure the model is there. Find the equivalents.
That's interesting.
Let me see.
Your pants.
You just put
Okay. How did you pick
12 on.
12
Well, I know 5 times 2, that's a 10.
tenths?
I know 5 times 2 is 10, so I did
Okay. What would this equal in tenths, and what would this equal in tenths?
Wait, what?
I want to know that.
Well, that's like half of
Is it?
Oh, there's the back?
How many?
Whoa!
Work on that.
What was the question?
When it's time, when we're done with the lesson. Okay, where's your model? I want to see the model because that shows me if you understand the word. Okay, this is 3/5 plus 1/2. I want to see what the equivalency is. What is that equal to?
So this is this,
How you doing, girls?
and then this thing right here. I'm having a lot of trouble with this, are you?
How you doing? So you have this is your whole, right, Sarah? Sarah's built, I'm going to borrow this, 1/2 plus 3/5. What denominator might we use? What's going to work for halves and fifths? Clara thinks tenths. What do you think, Sarah?
Yeah,
Yeah, why make tenths work, Clara?
they both go into
So 10 is divisible by
both of them.
both of what?
5 and 2.
5 and 2. So how many do you think we need? Is it more? That's okay, come. Is it more than a whole?
Yeah.
So will 10 tenths be enough?
No.
No, because that's a whole, right? How many might we need?
11.
She was telling me. Do you think 11? Why don't you try it? 11 tenths. You might have to borrow one from Clara.
You use your tenths and you can have this one.
All right, perfect. So let's see if it works. So line it up right here. Did it work?
Yeah.
Yeah. How
We
many?
have to make that into a mixed number.
Hmm?
We have to make it into a
We do have to make it into a mixed number, but first, how many tenths is 3/5 equal to?
6.
Do you count them up. Check her. Check if that 3/5 is the same as 1/10. 1, 2, 3, 4, 5, 6. Is this right? How many tenths is 1/2 equal to?
5.
Check her.
Yeah.
So how many total tenths do we have?
11.
11 tenths. Now, that doesn't seem, that's what, an improper fraction. So how could you change this?
Make it into a mixed number.
Show her how you're going to make it into a mixed number.
Here
Alright.
is
Where's your
my
work?
10
Where's your work?
and yours.
Where's your work? How am I supposed to know? Okay, but it wasn't 5/5, it was 3/5 and a half. What are you going to use?
10 times 2 is 20. So 2 times 1 is 10.
That's what I want to know. Snap once, snap twice. Once you get your number and you decide on your common denominator, something seems improper about it. Make sure you simplify it or write it the correct way. We'll talk about that in a second. If you are done with that problem and you feel confident, Evan, Bennett, Charlie, Devin, Maverick, Colin, you can work on the share and show next. Go ahead. I'm going to come right back to you, and then I'll work on this with you, okay? Give me 1 sec. Yes. Okay, give me 1 sec. What do you got?
It equals 1.
I have 1 and 2 20ths.
No, well, you can say that, but you want simplest form. Yes, move on. You need to be working on this. You need to be working on this. I have challenge problems for you, but you need to do your work first. How'd you do? Good? How'd you do? What'd you get? You need to do the work on here. Put your answer. How'd you guys do?
So you have your fifths.
Base?
Do you see how it's more than a whole?
Ten. tenths, that's tenths, and that's 16ths. And that's not going to be simplest. It will work, but it's not simplest.
So you take the 10.
You should be able to model it, right? Let's try that again. All right, Kelly and Julia, Jenny, Grace, come to the back table. Can you girls go to the carpet, please? Yes, you just have to make it into a whole number now. And a part.
Should we bring our stuff?
Yeah.
I would bring.
Julia, Kelly, bring your papers and your blocks, please.
I got it.
Oh, okay, then you can continue on your own phone. If you, Grace, if you want to join the 4 on the carpet, you can.
What, you want me to show Jenny?
No, I'll work with it. Charlie, can you bring me... Never mind, we're good. Okay, let's model it together. So we have a whole. We have 3/5, I'm stealing yours for a second, and 1/2. So we should have that modeled. That's our first thing we're going to have in front of us. Switch it so that's easier to line up. Now what we have to do is find out a way to find the equivalency to that. It has to have a common denominator. So it has to have the same value, but have the same type of units, the same denominator, the same name for our units. So one way to do it is to check what will work. First of all, you know it's more than a whole. So whatever it is going to be more than a whole. You can try different things, but because I'm going to be thinking about 2 and 5. They need a common, what? You said it 4. Multiple. Can you think of something that if you did multiples of 2 and then multiples of 5, what you would get? So what should we try? Try it. Now, we're probably going to have to trade off or borrow, but you can, there you go. So you have how many here? 10 tenths, right? But this is more than a whole, so you'll probably need what? Think about it with Julia. You probably have to share materials. Molly?
We were wondering if we have to use fractions.
I want you to model a couple of them, yeah.
Okay, so should we do like 2?
Yeah, that's good. Okay, what do you need? Another tenth, so how many tenths total?
11.
11 tenths. So when you write your problem, you have 3/5. Well, 3/5 is equal to how many tenths?
6.
Yeah?
I get it, Anna.
So 3/5, Julia, is equal to how many tenths?
3/8 plus what? Wait, and 1/2 would be equal. 5.
5 tenths.
1/2 plus 3.
Did you see it, Julia? Look at where'd your model go? You keep getting rid of your model. You need that.
Then 6 plus 5 would be 11.
What was the other one? Yeah, so 11 tenths. That's your model, right? Okay, well, we can use it though. 3/5 is how many tenths?
It equals 7/8.
6. So 3/5 is equivalent to 6 tenths. How many? Bennett, I appreciate what you're saying, but you need to find a more kind way to say it. 1/2 is the same as?
We're having trouble for what to write on it to make connections.
Okay. You're renaming them as what they're equivalent to in whatever unit you use. So use tenths. So what is 3/5 as tenths?
Oh.
And what is 1/2 as tenths? And then putting it together.
Okay.
Okay, now the last step is to put that together. So 6 tenths plus the 5 tenths. What is it when you put all of those units together? I think Kelly had it modeled for the two of you. What's the total?
Wait, Zafrin, actually. That's a lot. Let's go.
You're okay, Jenny, now?
Yeah.
I have challenge work for you. I'm going to be right back. I want you to combine that to put the bottom. What is it total? 3/5 plus 1/2 is the same as 6 tenths. And 5 tenths, right? You just proved that to me? model that out right here. I'll be right back. I'll be right there, Sarah. Wait, me and Cody. Yep.
Finally, I organized. Dang it. Finally. Okay, so look. Half and then a half.
One foe,
Half cards.
3 foes. One foe equals 3 foes.
No, you're not going. 15 minutes, but you'll make it up another time. I already talked to them. Snap once, snap twice. As you finish your share and show, there are task cards in the green bin and Mega Math set up on the Chromebooks. I'm sorry. So you can go to either of those activities I've set up for you once you finish. Then that's what you should go to. Then you have to just add it. You'll get an improper, and then you'll go and make it. That's okay to get an improper. Then you're gonna fix it. What could you also name it as, just like you have here?
Can I help with the adding? I got 1 minute. Yeah, 1 minute. Okay.
That's helping you solve it, or is that what? So who can explain to me, answer our essential question, how, using fraction strips, how does it help us to find like denominators so that we can add our fractions? Or even, how did the modeling help you? So who can answer that question for us? Explain how using fraction strips with like denominators made it possible to add fractions with unlike denominators. Who can give me an example from their work? How did using fraction strips with like denominators help us to solve problems with unlike denominators? Everyone should be thinking about this. I'll give you time. Explain how using fraction strips with like denominators, when you found the one that worked, right? Like denominators, make it possible to add fractions that originally had unlike denominators. Grace.
It can help because when you compare the two, or when you compare the fractions, you can see, like you can hold up the different blocks and see if the blocks will fit into other blocks. That way.
So what are you checking for when you see if you're saying fit in?
You can see if they're equivalent.
You can see if they're equivalent. Who can revoice what she just said? You might have to say it again. Say it one more time, Grace, and turn towards them.
The blocks, you can see if they fit into each other, like you can see if they're equivalent.
So you can see if one fraction, Grace, is this what you're saying, is equivalent to another fraction? So who can build on or revoice that? I want somebody to make sure we understand how we use those fraction blocks. See the same hands. I need more people. Billy, you need to be with me.
Oh, sorry.
Thank you. How can we use fraction blocks, Maddie and Ronan? I want to know from you. How do we use fraction strips with like denominators to solve problems where they have unlike denominators? What did we do? Go ahead, Ronan.
You add it on to see on different fraction blocks to see if they get up to the same height.
Okay, so when we're checking for the same height, what are we really looking for? If they are what?
The same.
The same. Maddie, what word do we use in math for if they're the same?
Equal.
Equal, or we talk about fractions being what, Brody? Equivalent. So Maddie, bring it all back together. Why do we use fraction strips with like denominators? To figure out addition of unlike denominators? You can build on what Grace said and Ronan said. Okay, one more time, Grace and Ronan, you're gonna have to tell Maddie.
Okay, so the fractions, I was going to say that you can hold up the different blocks, and the fractions look, and you can see if the fractions are equivalent to other fractions to help you solve the problem.
So you can check if fractions are equivalent to other fractions, and then Ronan added on that you really are checking if the fractions are equivalent and that they have what as the denominator? Like denominators. So what's that word? Equivalent denominators or common denominators. So using those fraction strips, we were able to look at, here's 1/4. What is it equivalent to? Here's 1 third. What is that equivalent to? We wanted to make them have equivalent fractions or common denominators. So let's look at our model once just so we have it. If I have 1/2 and I add 1/4, who thinks they know what with a common denominator we would use? I have 1/2 and 1/4. What might work for both? What common denominator will they have? Maddie and Ronan, I need you to focus up here. What common denominator, Grace? 1/4 and 1/2. What might I use on both of them? Sarah, are you thinking about that problem? Oh, I should see more hands than that. 1/4 and 1/2. How could I split them into pieces so that I could have a common denominator? Sarah, what common denominator could I use that they all break into?
Um,
I had my 1/2 and I had my 1/4. They broke them into what common denominator?
4,
4ths. So how many 4ths do I have here?
2,
How many do I have here?
1,
How many total?
3,
3 what?
3/4.
3/4. We're going to continue to practice this.